Okay, yes, we are set. So, good evening, everyone. So, we'll be continuing the next class on transformation of axis. So, yesterday we discussed the basic, the first type of transformation, that is the translation of axis. The definition of transformation of axis is that it is the process of changing the coordinates of a point or an equation to a locus by the virtue of change of origin or or the rotation of axis. So first type of transformation is translation of axis, in which the x-axis and y-axis, their orientation, the angle will remain the same, and yeah, someone is asking, is this useful for 11th? Yes, very much. It is part of straight lines. To understand straight lines concept, you need to do this. You need to learn this particular topic. So transformation. In translation, we move the coordinate axis to a different point straight away without any um, rotation. We just move it to a different point. In rotation, what we do is just hold on 1 minute. Yeah. In rotation of axis that we'll be discussing today, we will not shift the origin. However, we'll just rotate the axis by an angle. And then you can have both translation and rotation. So yesterday we did this one, translation of the coordinates, translation of the origin. Okay, I'm again explaining. I'll once again explain. So P is a fixed point in plane. Okay, this point P is fixed in a plane. Now we can choose the origin according to this blue origin here, the blue O, with the original axis in x-axis and y-axis in blue. This is the original set of coordinates. With respect to this coordinates, with respect to this coordinate axis, x-axis and y-axis, which we are representing by small x and small y, the coordinates of P, is x small x comma small y. Because any point P, we give a coordinate x comma y with reference to an origin. This was the very first class we discussed. We always have a reference to the origin. So now, if this is small x comma small y, it means that from origin you have to move x distance along the x-axis and y distance along the y-axis to reach the point x comma y, this px comma y. So this length will be x and this length will be y, small x small y. Now for some reason we shift the origin, we translate the coordinate axis to a different origin. So now the origin is shifted to h comma k. This h comma k is with respect to the original coordinate axis, not the new coordinate axis. This new coordinate axis is shown in red. H comma k, this coordinates h comma k is with respect to the original coordinate axis. The actual coordinates here in the new coordinate axis will be 0 comma 0. These are the new coordinates. but with respect to the old coordinate axis, this is h comma k. Now similarly, P is the same point situated there, only thing is axis has changed. So with respect to the new axis, new x-axis and y-axis, let the coordinates of P be capital X comma capital Y. Then what happens? We want a relation between this small x and this capital X, and this small y and this capital Y. Now, based on our basic definition of coordinate system, again, this point P has the coordinates capital X, capital Y with respect to the new origin. Therefore, to reach P, we have to go capital X distance along the x-axis, capital Y distance along the y-axis. So this distance is capital X here. And this distance is capital Y. So this distance is capital X, this distance is capital X, this distance is capital Y. Okay. So now, naturally now, this point with respect to the old axis is h comma k. So to reach this point, we have to move h units along the x-axis and k units along the y-axis. So this distance is h, this distance is k. So now, just by observation, geometric observation, we can see that the small x is equal to, small x is equal to capital X plus h. This small x is equal to capital X plus h, and the small y is equal to capital Y plus k. So this will be the relation between new coordinates and the old coordinates. Okay, is this clear? Can I see someone had raised that it was not clear to you? So I just repeated, and I'm sure yesterday. Now is it clear? I'll do one or two problems. It will make it more clear. Siri, I'm asking you. You raised a question. All right. Now I'll give a small question on this. Maybe that will clarify. I'll give a very simple question. Example 1. Let's say a point P has coordinates 2, 3. 2, 3 in with respect to a coordinate system, with respect to a reference coordinate axis. If the axes are translated to a new origin located at say 3, 4. Okay, then find the new coordinates of P. So here your small x was 2 comma 3. Small x is 2, sorry. Small y is 3. New origin h equal to 3, k is equal to 4. So what is the relation? This is the relation. So small x is equal to capital X plus h. Small y is equal to capital Y plus k. So this implies small x is to capital X plus 3, and this implies um, small y is 3 is equal to capital Y plus k, k is 4. So this gives us capital X is 2 minus 3, that is minus 1, and capital Y is 3 minus 4, which is minus 1. Therefore, the new coordinates of P are minus 1 comma minus 1. Got it? Got it? So I'll just show you here. So this was a point 2 comma 3 was our point. Now we wanted a new set of axes. The new set of axes, I'll just copy this snip and put here. Okay. So there's the coordinate point here that we were considering. Now the new set of coordinate axes will be here. I'll just draw. Now 3 comma 4 was the new set of new coordinate axis. So just look at the figure. This is the new origin. With respect to the old origin, its point was 3 comma 4. Now this was 2 comma 3 in the with respect to the old origin. With the new origin, now you see with the new origin, for the new origin, this will be 1, this will be 2, this will be 3, this will be 1, 2, 3, this will be minus 1, and this will also be minus 1. So this point A will be minus 1 comma minus 1. This 2 comma 3 will become minus 1 comma minus 1 in the new system. In the old system, it was 2 comma 3. Clear? So this is the effect of translation. Your coordinates will change. Now equations will also change. So we just have to replace the equations. I'll come to that. How equations of locus change. Right now I'm just doing the translation. So just remember this one. this result, small x old is equal to new plus the new coordinate, new origin. So it is small x is equal to capital X plus h, small y equal to capital Y plus k. Next, coming to rotation of coordinates. Rotation of axis without shifting the origin. This is okay. Now let us do this. This is something that students usually they don't get it right in the first time, but we will see this. It's not very difficult. Okay, so this is your old coordinate axis. Now P is some point here. Now with respect to the old axis, its coordinate is small x comma small y. This is the origin. Now I want to rotate the coordinate axis. So I rotate the coordinate axis about the origin without, you know, without moving the origin. Okay, so let us say what is the new set of origin. Let's say this is the this violet colored line. This is the x-axis, capital X, and this is capital X, and I've just rotated it. All right. This is capital X, capital Y. Okay, so the origin remains same. The origin remains same here. Now, what will be the coordinates of the point P in the new system? Let's say in the new system, the same point P will now have coordinates capital X, capital Y. So what is the relation? Now, let us say this axis have been rotated by an angle theta. Just a second. So axis is rotated by an angle theta. So now let us just draw a few lines. First, from P, you drop perpendiculars to the old coordinate axis. That's the first step. Right? So this is perpendicular, so this distance will be small x, this distance will be small y. Now again we drop perpendicular from P to the new coordinate axis. Okay, all right. So now you just observe this. We want, so this is capital X, this is capital X, by the way, this is capital Y. So let us say this P, we'll say M dash, this is M, and this is N, this is N dash. Okay, so this P M dash is capital Y, P N dash is capital X, O M dash is capital X, P N dash is capital X, O M dash is capital X. All right. Now this is small y, this whole thing. Now let us see. We just have to equate. Now when you rotate this by an angle theta, okay, what will be this angle? This angle will also be theta. Why? Because horizontal lines I'm rotating by x. This is a vertical line. So the vertical axis, the horizontal axis, small x to capital X, the rotation is theta. So the verticals will also get inclined by theta. Or the other way to see is, this is theta, this angle is 90 minus theta, all right? And so these will be alternate angles in geometry. So this is 90 minus theta, and this is perpendicular again. If this is 90 minus theta, this will be theta. Got it? Now, so I don't want to emphasize this part because I want to draw something there. So understand that this is this is 90 minus theta. Now I drop a, vertical, a horizontal line from M dash. Okay, and let's say this is M N O P Q R. I'll just write this as R. M dash, I'll just put this as R dash, and this is R. Okay, now we just have to write different distances. That's all. We just have to use basic trigonometry. In the basic trigonometric angles, this is the opposite side. Okay, opposite side, this is the adjacent side, this is the hypotenuse. So sine theta is opposite side by hypotenuse, cos theta is adjacent side by hypotenuse. These are trigonometric ratios, and tan theta is sine by cos. So now we observe, say this triangle, we observe O R M dash, O R M dash. Okay, now in this is capital X and this is our small x. OM, I'll mark here. This is small x and this is capital X. So now, what is OR in triangle? In triangle OM dash R. All right. We get cos theta as OR by OM dash. Correct? In this triangle, OR, there will be adjacent side to angle theta, and this is OM dash is the hypotenuse. So OR is OM dash cos theta, right? Now OM is nothing but OR minus MR, correct? OR is OM dash cos theta. This will put 1. Now OM is OR minus MR. So when you do that, this MR is same as R dash M. I'll just reduce this. So this which is same as OR minus M dash R dash here, M dash R dash. Now this M dash R dash, you look in this triangle. In triangle, I'll put here, in triangle P R dash M dash, this will be the opposite side. Okay, sine theta is M dash R dash upon PM dash, which implies M dash R dash is PM dash sine theta. Okay, so this is your equation 2. This I'll say this as equation 2, this as equation 3. So substitute substitute 3 in 2. What you get is OM is equal to OR minus R dash M dash R dash, which is equal to, write this, OR is OM dash cos theta from 1 minus PM dash sine theta. Now what is OM is small x. What is OM dash capital X? What is PM dash capital Y? So you get this result. Small x is equal to capital X cos theta minus capital Y sine theta. All right. This is what you get as the first expression. Very important. There's a very easy way to remember this. I'll teach you at the end. First, I'm just giving the derivation of this. How do you get this? So this part was the difficult part because this was x This was capital X. The projection of this OM dash is OR. So from there, I had to do this OM is OR minus this distance. This distance comes from here. So all those things I have to do. This Y part is very, very straightforward. Okay. You see this here. PM is nothing but this PM is nothing but M R dash plus R dash P, or I'll just put MP here. Next, MP is equal to MP is equal to M R dash plus R dash P. Now MP is capital is small y. Okay, MP is small y, and M R dash is same as R M dash. This length. Okay, this length is equal to this length. Now from here, this is on the opposite side. So in the same triangle, in this same triangle, in triangle OM dash R, cos theta is this, and sin theta is this M dash R by OM dash. And here, similarly, in this triangle, P R dash M dash, sin theta is this, and cos theta will be the other way. I'll just write here. What will be cos theta? In this one, cos theta is P R dash upon P M dash. P R dash upon P M dash. Okay. So from here, P R dash is P M cos theta. So or RP. So from 1 and 2, this MP is Y, small y. M R dash from here is OM dash sin theta. Plus this P R dash is PM dash cos theta. What is OM dash? Capital X sin theta plus PM dash is capital Y cos theta. So we are done. Actually, it's just a matter of geometry, how keen you do the geometry part of it. So in problem solving part, we are not worried about derivation. In boards, maybe they will give a derivation for which you have to go through this thoroughly. You have to, if you want to learn the derivation, you go through what I've told and again sit down and repeat the whole derivation yourself. Okay, wherever you get stuck, from there you will know, clarify it and do it. So this derivation is little tricky, not so straightforward, but because you are first year students, it is little, class 11 students, it is little tricky, otherwise it is easy. But the final result is easy. Final result is not difficult. Okay, final result I'll write in a combined form. Just see how the way I write. In a combined form, therefore, the relation between the old coordinates p x comma y and the new coordinates p capital X comma capital Y is this. Very simple. Just see this. I write small x small y. Now I have x, y, capital X, capital Y here, capital X, capital Y, capital X, capital Y. Just write cos theta minus sin theta, sin theta plus cos theta. This will be the relation. Small x is equal to capital X cos theta minus y sin theta. Small y is equal to capital X sin theta plus y cos theta. All right. If you have learned matrices in class 10th, 2 by 2 matrix, then in matrix form, this can be written even more nicely. This is a column matrix. This is a column matrix. The transformation matrix is, cos theta minus sin theta, sin theta and cos theta. Okay, so this is another way to remember the same thing. Remember, cos minus sin, sin cos, cos minus sin, sin cos. This is how you have to remember. This is from old to new. Okay, old is equal to this transformation into the new one. Now I want to find, you said okay, this is this way. How about old coordinates in terms of new coordinates? We can just solve this equation and find out. I will directly write the solution now. Maybe I should write here beside this only. Now the new ones in terms of the old will be capital X capital Y, write small x small y, small x small y, and just this reverses cos theta plus sin theta minus sin theta plus cos theta. Those who know the matrix inversion, if you don't know, do not worry about it. Once you do matrices, you will know. If you invert this matrix, okay, AD minus BC is cos square theta plus cos square theta, that is 1. And then DA minus B minus C is the inverse. So it turns out to be like this. Capital X, capital Y is equal to, in matrix form, cos theta sin theta minus sin theta cos theta multiplied by the old. Those of you who don't know matrices, the basic matrices must have been introduced in 10th. But those of you who are not familiar with matrices, don't worry about it. Take down this result When we do matrices, this will make so much meaning for you. You will remember this formula more easily than this one. This one you will tend to forget, but this one you will not forget. Okay. And if you remember this, automatically you can derive this. So old in terms of new is x cos theta minus y sin theta, and y is x sin theta plus y cos theta. Now new coordinates in terms of the old is x cos theta plus y sin theta, and capital Y is minus x sin theta plus y cos theta. So the sign of minus has shifted from this top right corner to the bottom left corner. That's the difference. This is how you have to remember. Remember this. Once you remember this, it is easy. It is not difficult. So even if you don't remember the full derivation, what we have done, if you just remember this final result, it is good. It is very important. Have you taken down? This was more difficult than the previous. Can I move forward? Have you copied? Okay. So now, when you do rotation and then translation, axes are rotated by theta, and then this rotated axis is again shifted to another point, another new origin. Then what happens? That is two step. This is translation and rotation. Translation to h comma k and rotation by angle theta. So in this situation, what we do, two steps. Okay, first it is translated and then it is rotated. So step one, okay, so I will say we want the final coordinates. XY first gets translated to, I will say, x dash y dash, and then again after rotation the coordinates change to capital X capital Y. The same point P changes like this. So first step is translation. In translation, the new coordinates, the old coordinates is the new coordinate plus h, y is y dash plus k based on the previous result. Origin of the coordinates is shifted to h comma k. So this is the transformed coordinates. The relationship between old coordinates and new coordinates is this for translation. Okay. So now we get capital X dash is small x minus h, and capital Y dash is small y minus k. All right. These are equation 1. Next we do rotation. Remember, we want the new coordinates. We don't want the old coordinates. We want to find which is the new coordinates. All right. So the new coordinates for rotation, this is the rotation. This is the new coordinates. This is the old coordinates for rotation. So you have to use this result. So you get capital X, new one, is x dash cos theta plus y dash sin theta. And here you get minus x dash sin theta plus y dash cos theta. All right. So now this is 2. This is on rotation. We got this. So this is translation of, so x1 becomes xy becomes x dash y dash in translation. Rotation x dash y dash becomes xy. Now combining 1 and 2, we get, combining 1 and 2, we get, you see, you substitute this x dash as x minus h and y dash as y minus k in this equation. So you get capital X is small x minus h cos theta plus small y minus k sin theta minus small x minus h sin theta so this is the result. This is the relation between the old new coordinate axis in terms of the old coordinates. I would recommend you just remember the first two. You don't have to remember this one. This you should do by two-step method. That's all. By logical transformation. By logic, you do the transformations, 2 steps. Now, shall we do some simple problems? These are very important from IIT JEE mains point of view, and you will use in very critical cases in coordinate geometry when you do straight lines. And unnecessarily we are not discussing this. This is a very important topic. You will come across in straight lines the application of this straight lines and then coordinate systems also. Coordinate equations for circles, parabola, ellipse, hyperbola. In that this will be useful. So have you taken this down? If yes, just put chat, then I'll do 1 or 2 problems.
Sir, can you scroll up?
Up, previous one?
Yes, sir.
Okay. This one or more?
More, sir.
This part?
Yes, sir.
Okay.
So you can scroll down, sir.
Okay. Done? This part is done?
No, sir. One.
Okay.
Done, sir.
Okay. This part?
Yes, sir. Done.
All right. Okay. So now we'll do some examples. Now I will be sharing with you this particular assignment sheet. So we'll take problems from here itself. Okay. Uh, I will do a few problems here and few problems I'll leave it for you to do this. They're a good set of problems. So just a second. Yeah. Let's do the first one. So these are the problems that we'll solve now. Numerical problems. So let's do the solution to the first part. Find the transformed equation of this curve x minus a whole square plus y minus b whole square equal to c square when the coordinate axes are transferred to a parallel position through the points. So through a parallel position, that means there is no rotation of axis. It is only translation. It is no rotation. And you will learn in the further chapters of coordinate geometry that this is an equation of the circle with center at a comma b and radius c. But now for now let's move forward. So given curve is this. Small x minus a whole square plus small y minus b the whole square is equal to c square. Now he says find the transformed equation of the curve. Now, so in the new set of coordinates, we need this equation. So the origin is shifted from 0, 0 to a minus c comma b. So this is our h comma k. All right. This one is h and this one is k. So now the relation between old coordinates and new coordinates is small x is equal to capital X plus h. What is h? A minus c. Small y is equal to capital Y plus k is b. Okay. So now substituting this in this equation. Substituting the equation of the curve. So small x, so this is x minus a the whole square plus y minus b the whole square is equal to c square. So you get capital X plus a minus c minus a the whole square plus capital Y plus b minus b the whole square is equal to c square. So this A cancels, B cancels. So we are left with capital X minus C the whole square plus y square is equal to C square. This is the transformed equation. This is the transformed equation. All right. Done. Yes. So I will upload by evening in another 1 hour. I'll try to upload on the Moodle site these notes. Okay, and I'll also upload this assignment. So you try to solve a few problems from here. Okay, some of them some of them are straightforward. Some of them are little tricky. But at least 3 to 4 problems you can solve based on what I have taught today. So you attempt it. In the next class, we'll discuss again. And the next class, remember, for coordinate geometry, today is Wednesday. So next class will be the coming Monday. Tomorrow onwards, tomorrow, day after, and Thursday, Friday, Saturday, we will have um, sets relations. We have completed sets. We have just started, Cartesian product. So tomorrow and maybe the coming 3 days, we will be discussing relations. Okay, so any questions you have? Any further anybody has to clarify?
Sir, in rotation of axis, sir,
Yeah.
do we use any physics application? Like in physics, we have torque.
Ah,
So
in
do we use over here?
in physics we have torque.
Torque,
Ah,
like
yes.
tau. So do we use that application in rotation of axis?
No, generally understand this way. The mathematical concepts are used in physics, not the other way
Mm,
around.
okay.
Mathematical concepts are used in physics whenever necessary. So sometimes rotation of axis is maybe required. For I'll give you an example. Um, see, let us say I'll just give a simple example. Suppose you are doing a problem in physics uh, with on a body. All right, the body is like this, but your original system of coordinates are you know rotated. It is not you know the original system of coordinates maybe this way. Uh, okay, this may be your x-axis, this may be your y-axis. Now you have problem where forces and other things are acting. It may be easier for us to choose the coordinate axis as this. All right. So uh, then the problems may get solved easily. The mathematical part will become easy to solve. So therefore, we may use problems in problems such as this. We can use transformation of axis. I teach engineering courses. I teach solid mechanics course. So in that, there is to find out stresses on a plane, we have to do a rotation of axis. We have to use this concept of rotation of
Okay, sir.
axis. So we have applications of this in physics.
Okay.
All
Thank you,
right.
sir.
Thank you. Good question. Anybody else has anything before we stop? All right. I would like to interact with any two students today. I said once a week I'll interact just to know how you're doing, any difficulties you have. 5 to 10 minutes I'll interact. Who is ready to interact with me today? Then in turn wise I will do that. If you volunteer, otherwise I'll volunteer for you. Okay, today I'll interact. No one is coming forward. Don't be afraid. Huh? See, you're teaching, learning will become very effective when you be free with the teacher. So for that purpose only. And I just want to know how is there any difficulty for you on a personal basis? I will have a private meeting. It's not a public meeting. So I'll meet today with Mahita and Asjat. Is that be okay?
Yes.
Tomorrow, tomorrow I'll do with others. Okay. So others can log off today.